Today we're solving radical equations and inequalities. Our learning targets: I can solve radical equations and I can solve radical inequalities. Now, just as a review, for any equations, and this was way back when we started the course this year, when you are solving equations, there's three things you always need to remember. The first thing, you are trying to get the variable by itself. The second thing, you always use the inverse operation. So remember, if it was a multiplication equation, to undo multiplying, you would divide. To undo adding, you would subtract. And then also, whatever you do to one side, you must do to the other. So these three things you still have to keep in mind when you're solving radical equations. And that's what we're going to start with, is solving radical equations. So for this first problem, for example 1, we're going to solve the square root of 4x plus 1 equals 3. And to do that, think about what the inverse operation is. What's the inverse operation of square root? And the inverse operation would be to square both sides. And that's what we're going to do, because the inverse operation of square root is squaring. So we're going to square both sides, because whatever you do to one side, you do to the other. So remember those three steps when solving equations. Well, when you square a square root, that undoes the square root, so you're just left with what's inside, 4x plus 1, and 3 squared is 9. And now, look, it's just a regular equation that we can solve. Subtract 1 from both sides, and we get 4x equals 8. Divide both sides by 4. Those cancel out. We get x equals 2. And we could check our answer. If you substitute a 2 back up in here for x, 4 times 2 is 8, plus 1 is 9, and the square root of 9 is 3, so it works. So really the only thing you have to remember that's different from other equations we've solved is to undo square roots, you square both sides. All right, for our next example, what we're going to do on this one, we want to solve this equation. And the first thing you have to do is you have to isolate the radical. So we have to get the square root part by itself. So I have to take care of this subtracting 3 right here, and I'm going to do that by adding 3 to both sides. So this cancels out. I get the square root of z minus 6 equals 3. Now it's like example 1. So you do need to remember what I wrote over here, and you should write this in your notes as well. Isolate the radical. So that's important that you do that first. Then you can square both sides. So when we square both sides, I'm squaring square root. So I end up with z minus 6. Again, remember, when you square a square root, it just cancels out the square root. 3 squared is 9. And now I just add 6 to both sides. These cancel. We get z equals 15. And when we check our answer, because you always should check, even if you don't write down your check. Look up here, if you put a 15, 15 minus 6 is 9, the square root of 9 is 3, and 3 minus 3 is 0. So we can see that it works. All right, here's the next example. The square root of x minus 5 equals the square root of 2x minus 4. Well, now this is different because I have square roots on both sides. I don't have to isolate the square root because there's nothing else with it on the side. So I'm just going to square both sides. So when I square both sides, I end up with x minus 5 equals 2x minus 4, because it's going to cancel out the square root on both sides. Now I have to solve this, so I need to get the x's on the same side. I'm going to subtract, I'll do that. Subtract x from both sides, so that's going to cancel that off of here, so that I'm going to add 4 to both sides. That will cancel that off of that side, and I'm going to be left with x equals -1. And I'm going to check my answer. So if I substitute a -1 onto the left side, I get the square root of -1 minus 5, which is, well, and on this side, I would get 2 times -1 is -2 minus 4. So I get the square root of -6 equals the square root of -6, which looks like, you might look and say, well, it's true, it works out on both sides, except the problem is the square root of -6 is, there's no real solution because you can't take the square root of a negative. Think about what number could you multiply by itself to get -6? So the answer to this problem is no real solution. If you are working out a problem and when you substitute it back in, it gives you the square root of a negative, then you will say no real solution. Which is why you should always check your answer, because if you hadn't checked your answer, you would have written down -1 and it would have been wrong. And you can double check that. If you do the square root of -6, you get an error, but look at what the error message says, non-real answer. So the error message on your calculator will actually tell you what the problem is. And actually, that's what I'm having you do here next. Evaluate the square root of -4 on your calculator. And when you do that, as we just saw with the -6, you get an error message, non-real answer. And the reason why is because there is no number that if you square it, you get a -4. And so that's why it's no real answer, or a non-real answer. So if you look at the expression, the square root of 2x plus 5, what must be true about x? Because that's going to be important in some of the problems we do. Remember, you cannot have a negative underneath the radical sign. By the way, and I've mentioned this before, underneath the radical sign is called the radicand. And so for this problem here, the radicand can't be negative. So it must be greater than or equal to 0. So 2x plus 5 can't be negative. So it can be positive or it can be 0. So this has to be true. Otherwise, we'll get an error message. So in this case, we can subtract 5 from both sides and divide both sides by 2. So in my question, what must be true about x? Well, if we're talking about the expression, the square root of 2x plus 5, then x has to be greater than or equal to -5/2. If it's not, then we would have a negative underneath the radical sign, and we would get an error message because it would not be a real solution. All right, that's it for evaluating or solving radical equations, and in the next video you'll see solving radical inequalities.